This is a video of how to do a p-chart. Of course, with a p-chart, you don't have to have an R-chart because you don't have a range because it's categorical data, or what your textbook refers to as attribute. It's either good or bad, and so there is no range, but there is a percentage. In the next video, I'll show you how to do a video for a simple frequency or an account or a C-chart. But we have here for 30 days. This is data from the supplement chapter 6, 6.18. They talk about it is a bank, and they took a sample of 250 records each day for 30 days. And they counted the number of defective records. So on day one of those 250, they had 7 defective records. So that meant the rest of them were fine. And so we have the ability to calculate a percentage here. And so they did that for 30 days. So let's go ahead and calculate the percentage here. So the percentage for day one, pretty simple formula here. It's simply the number of defective records divided by the total number of the sample, in this case 250. Now I'm going to absolute this, so when I copy it down, it'll go on to day 2, but it will stay at the sample size. It will continue to use that value. So this is 2.8%. We'll format it here quickly, but let me copy this down now. We'll kind of double check, just pick a number here in the middle. It's the number of defects on day 19 divided by the total sample size. So it copied down correctly. Let's go ahead and format these into percentages. So 2 decimal places should be sufficient. Now, of course, the key to this is to be able to figure out what the average percentage, or the p-bar. And so in this case, I'm going to do it this way. I'm going to just equals average, and I am going to highlight all of these averages for each day. And so that'll give me my p-bar. So the average is 4%. Now there's another way to do this that you can do real quickly. Instead of calculating the average for each day, I could simply take the total number of defects here. So let's do that. The sum, and we will highlight those. Oops. So we have a sum total of 300 defects, and so to figure this out, to figure out the average, if you take then the 300 defects and divide them by the 250 times 30 days, so that's the total number of 250 each day for 30 days. So that's the total number of things we did. You will see that we'll get the same answer. So either technique is perfectly acceptable in calculating that average percentage. Let me just format that so that you can see that it is exactly the same. Now with that, we're ready to calculate. This formula will be provided you on the formula sheet, but the formula is that we have to figure out a standard deviation, and what it is I recommend to use multiple fields. So the first one is that you have to figure out what the top part of it is, then divide by n, and then do the square root. So instead of trying to do this all in one formula, I'm going to do it in 3 parts. So we take the average percentage and we multiply that by 1 minus the average percentage. And so that's the top part of the equation. So the percentage times what's left, or the opposite of that percentage. That gives us the top part. Then we divide that by n. In this case, n is 250. And then we take the square root of that. It's much easier to make sure that the equation is done properly by dividing it into 3 different parts. And then what we're going to do is we're going to take 3 of these. This stands in for standard deviation, and so 3 of these. And so to do the upper control limit for the P chart, we simply have our average here, and we're going to add to that 3 times this value. And to do the lower control limit for P, we're just going to subtract then. So once again, we start off with our average here, and we will subtract then 3, that's our z value, times what this formula tells us. And so we have an upper control limit of, we probably don't need to carry all these decimals here, but we would have an upper control limit of 7.71%, so we will tolerate 7%, 7.7%, and we'll go as low as 0.28. Now we could do a graph of this like I showed you in the earlier video with the X bar and the R chart. You would do it the same way. You could copy these numbers down and then do a simple line chart. But we could probably quickly check the data here. 7.6 is still below our upper control limit, and I don't see any other anywhere the 7. In regards to the lower control limit, it doesn't look like anything is less than the 0.28, and so we would say that this process is in control. And so that's how you do a P chart.